we're developing that can be designed quickly and fast to predict safe rates for operating the subsurface. And here in this set of demos, there are also information how we can, information about geothermal properties within US. So quickly you can look and evaluate different areas for geothermal prospectivity. And this kind of analysis again can be based on a lot of geologic information. All this information can be quickly visualized. If people have proprietary data or additional information which is not part of this type of analysis, very quickly can be added, and the machine learning algorithms can make prediction about prospectivity for geothermal extraction and utilization. This is another example which is not on the dashboard yet. This is in the region of Nevada. Department of Energy and USGS invested huge amount of money to collect airborne geophysics data where they're flying airplane over a big portion of Nevada, and this is the footprint of the data that was collected with airborne surveys. And a lot of data is collected in the Great Basin about geothermal prospectivity, but with our tools very quickly can assimilate all this information and make estimates about geothermal prospectivity. And this is again one more example of what we are doing. I want to talk a little bit about energy because, as Kurt mentioned earlier, one of the key issues with AI is energy, and we need to think how to use these tools and what is their footprint and what is their impact on the environment. And it's very important to understand, again, I'll go back to this comparison between our brains and artificial intelligence brains. Through evolution, our brains were really extremely efficiently designed. We consume a relatively limited amount of energy to make decisions, to dream, to think, to enjoy movies with our brain. So this is the energy consumption of our brain every day. And when we look at energy consumption, the other factor which is, especially in the US, people in the US have, and also in the developed world, big impact of energy consumption. So this is when you consider how much energy US consumes, this is per capita what we consume as energy, every single of us, each day and over the year. Now when you're thinking, again, there is not a lot of information about how much energy it takes to train these large language models that ChatGPT and Google Gemini are developing, but there are a lot of estimates out there. This is no official numbers, but this is approximate estimate that I was able to identify. But when you think about this amount of energy, when you consider the people that can be trained to perform the same task, what will be the energy footprint of these people? It's almost like 8,000 people can be trained for this amount of energy, considering their energy demands for their everyday life. So it's almost thinking that it's like a building university. You have 10,000 to 8,000 people that you're training for 6 months, and after that you're turning into experts. When you consider how much energy is consumed to perform individual query, really the amount of energy is very similar to the amount of energy our brain uses. So there is a good parallel between these two numbers. But the problem is that, as Kurt was saying, at the moment we might face like 1 billion queries per day, which is huge amount of energy. And when I say 1 billion, I'm comparing how much queries Google is handling every day. I mean, we're talking about huge amount of queries around the world, people clicking and want to have an answer, and this is not small amount of energy. So, but this is also a huge amount of time thinking. I mean, if you think that 1 billion queries, 2 minutes, this is like 4,000 years of thinking. Somebody is thinking for 4,000 years every day. Can you imagine? I mean, it's unbelievable. I mean, think about evolution, because we talked earlier, billions of year evolution, and now we have machine learning algorithms which every day are thinking 4,000 years. I mean, it's incredible. And if you think how many experts potentially you need, if you want to replace this ChatGPT and Gemini to answer these questions within 2 minutes, I mean, it's incredible what kind of energy and is consumed, but also what kind of power this gives us, because it's beyond, I mean, for me it's challenging to comprehend these numbers. So we'll be much more efficient if humans are doing this, much less energy. But when you consider the total energy consumption for all these people really to answer this question, this is not small amount. And when you consider what is the salaries that need to pay to these people, I mean, I'm just saying it's incredible comparison. So going back to the energy, what I'm kind of emphasizing, we can use AI tools to help solve this energy problem. I mean, I don't think AI will go away. We'll continue using it, we'll need more energy, and we need to solve the problem. We need to produce more energy, we need to produce it in a more sustainable way, we need to be proactive and plan ahead. And AI can really help address these challenges. Geothermal is one of the primary candidates to provide cooling and also electric power for these data centers. So what we're doing with AI tools to solve geothermal problem, in some ways hopefully will address the issue with energy. And our tools really facilitate geothermal exploration and utilization. They also help with environmental concerns associated with data centers related to water usage and groundwater contamination. So in some ways I'm optimistic. I mean, I've always been kind of optimistic. Maybe I'm too much optimistic, but I believe that we can solve the problems and AI can help us solve these problems. So I will go back just to say who we are. I think we kind of emphasize ENVITRACE. Our company applies science, physics-informed artificial intelligence to solve energy and environment problems. We are going after a wide range of problems, not only geothermal, but also energy production and storage, waste management, contaminant characterization, induced seismicity, which is a big problem with any geothermal and waste disposal problems. We're dealing with in situ mining, especially critical minerals, which are also very important for our economy. Water energy food nexus, how all this complexity of water needed for energy production, for food production, for AI production, and the other way around, how all these things are coupled is a very important problem that we are addressing, and also issues related to urban monitoring and energy use. And what we're building is not only the AI tools, but a bunch of tools for pre-processing of the data, evaluating uncertainties, sensitivities, and all the way to making decision-making and life cycle assessment. We have been, as I mentioned, for more than 4 years. We have quite substantial amount of research funding. We have been successful to obtain. We have many research papers and patents and open source codes. Many of our codes are open source, so people can use them, not only the demos that I showed on the screen. And this is mostly to build confidence and acceptance by industry and public of the tools that we're developing. And this is our team, Trace, co-founder with me, and a lot of other smart guys helping us with work. Tori is here, our director of operations, and this is what we're trying to achieve. And there is no way to finish artificial intelligence and machine learning talk without XKCD cartoons, which are always very witty and nice to look at. Thank you.